Hey guys, Miss Farron here. Welcome to Unit 8, Notes 5. We're going to look at solving radical equations today. So our learning target is I can solve radical equations. There are a couple steps that go into solving radical equations. Remember, radical is just your square root sign. So if you see some equation that has the square root, that's a radical equation. And here's the steps you want to follow. So step number 1 is going to be to isolate the square root. So isolate means to get the square root alone. So we want to cancel the constant that's outside the radical, if there is one, or cancel the coefficient of the radical. So if there's a number in front or a number on the outside of the radical in the back, we need to get rid of those first. Step number 2 then is to square both sides of the equation. It's really important for you to know that a square root and a square are inverses of each other. So these two things are inverses of each other. One undoes the other. So just like multiplication is an inverse of division, a square root is the inverse of a square. And then our last thing is going to be just to solve the remaining equation for the variable. So a square root of x has only a positive solution. It's really important for us to remember that. Basically, because remember, if I'm taking the square root of x and that equals -4, there is no number that I can plug in, take the square root, and get -4. That does not work. So make sure that the square root of x has only a positive solution. If you get a -1, we just cross it off. And then also keep in mind, kind of like what we talked about up on top, the square root and square, these cancel each other out when you do them. That's because they're that inverse that we talked about. So the square root and a square, they cancel each other out, and you're only left with the thing that's underneath. So let's look at this first example here. I have the square root of x minus 7 equal to 0. So step 1 says to isolate the square root. So I'm going to go ahead and I am going to highlight the square root. This is the thing that I need to get alone. So to get that alone, I have to get rid of this minus 7. So to get rid of a minus 7, we know the opposite of that is to add 7 to both sides. So now I'm going to take the square root of x. This is going to cancel each other out, and I'm just going to equal 7. So now, step 1, isolate the square root. That's it. That's all that's alone, so we're good there. Step 2 now says to square both sides. So it's really important that remember that to undo a square root, we're going to go ahead and we're going to square this. What we do to one side, we have to do the other. So the square and the square root are going to cancel out, and I'll just be left with the x. 7 squared is going to give me 49, and I don't have anything else I need to solve for, so that is my final answer, and I'm done. Example number 2 here then. Again, I'm going to highlight the square root. So anything that's in the square root, that's what I need to get alone right now. So in order to get that alone, there is nothing else I need to do. It's done. I can go straight into step 2, which tells me then I can square both sides. I want to undo the square root piece. So I'm going to square this side, and I need to square everything on this side then. When I square a square root, I'm going to be left with just x on that side. I need to square both things on the right-hand side here, because remember, when you have something squared, it means you have this. I have 2 of them. So I'm basically doing 2 times the square root of 3 times another 2 times square root of 3. So think back to when we did that. We went and multiply the numbers in front of the radical. So I have 2 times 2, which is 4. Multiply the numbers underneath the radical. So 3 times 3 is 9. And then I want to try to simplify this. I know that the square root of 9 is 3. So I'm going to get 4 times 3. So my final answer is going to be x equals 12. So number 3 here, first things first, we want to isolate the radical. So I'm going to highlight everything that has it's inside the radical. So I need to get that alone. So to get that alone, the thing that's a problem right now is this 3 out front. And that tells me I'm doing 3 times my radical. So to undo timesing, we divide by 3. And we're going to divide by 3. So that canceled out, and I'm left with just the square root of x plus 4. And that's going to equal 15 divided by 3, which is 5. So I have the square root isolated. There's nothing else on the outsides that I need to get rid of. So from here, I need to get rid of the square root. So to get rid of that, we square both sides. That all cancels, and I'm just left with x plus 4 equals 5 squared gives me 25. And now this is where step 3 comes in. I need to solve for the remaining variable. So I need to get x alone. So to get x alone, we need to subtract 4. So x is going to equal 21. Example number 4 here. So step 1, we want to isolate the variable or the radical. So I'm going to go ahead and I am going to highlight the radical that I'm trying to isolate. So I'm trying to get this stuff alone. So to do that, I need to get rid of the 8 in front. So I'm going to divide by 8 because that's being multiplied. And I'm going to be left with square root of x minus 3 because the 8s are going to cancel. 16 divided by 8 is going to give me 2. So now I need to undo the radical. I need to get rid of the radical. So to get rid of that, we square it. What we do to one side, we have to do to the other. Those are going to cancel, and I'm left with x minus 3. 2 squared is going to give me 4. Last step then is get the x alone, so I need to get rid of the subtracting 3 by adding 3 to both sides. So x is going to equal 7. On to number 5 now. So again, we want to isolate the radical, so I'm going to highlight that. That's what I'm trying to get alone right there. So to get that alone, I need to get rid of the adding 9 at the end. We know that to get rid of adding 9, we subtract 9 from both sides. So I'm going to be left with the square root of 2x minus 3 is going to equal negative 4. Now remember, I cannot have a square root equal a negative. When I have that, that is called a no solution. There is no way that I can plug a number into my x there, take the square root of it, and then get a negative number. Example number 6 now, same steps. We're going to highlight the radical. So this is the thing that I want to isolate. To do that, I need to get rid of the minus 2. So I'm going to go ahead and I'm going to add 2 to both sides. So I'm going to have the square root of 3x minus or plus 1 is going to equal 8. So now to undo the square root, we're going to square. We do to one side, we got to do the other. So I'm going to be left with 3x plus 1. It's going to equal 64. And now I just need to finish solving for x. So we know that we get rid of the adding and subtracting first. So I'm going to be left with 3x equals 63. Divide by 3. And I'm going to be left with x equals 21. So number 7 here, same steps. We're going to isolate our radical. So I'm going to highlight the radical. That's what I'm trying to get alone. So the thing that's not highlighted, I need to get rid of. I need to get rid of the 5, and it's being multiplied, so I'm going to divide. So I'm going to have x plus 1 is going to equal 1. To get rid of the radical now, we go ahead and we square it. What you do to one side, you got to do to the other. So I'm left with x plus 1 is going to equal 1. Careful, 1 squared is 1 times 1. Finish solving for x, we subtract from both sides, and I'm going to get x equals 0. Don't let that throw you off. Remember, 0 is a good number. We like it, so our answers can be 0. Number 8 then, I'm going to throw everything at you for this one. So step number 1, we're going to highlight the radical, and we're going to get this thing alone right now. So I have 2 things I have to get rid of. I have to get rid of the timesing by 3 and the adding 5 at the end. Remember, we always get rid of the adding or subtracting first. So we're going to get rid of the adding 5 by subtracting 5. And I'm going to be left with 3 square root of x minus 4 is going to equal 18. So now I still have a radical, and we're still trying to get it alone. So again, this is what I'm trying to get alone here. I'm going to get this piece alone. So I'm going to go ahead and I'm going to get rid of that timesing by 3 by dividing by 3. So I'm going to be left with the square root of x minus 4 is going to equal 6. Now, to undo the square root, we square it. What you do to one side, you got to do to the other. So I'm going to get x minus 4 is going to equal 36. Finish solving for x, I add 4 to both sides. So x is going to equal 40. So when we are dealing with these radical equations, we're going to come up with extraneous solutions in some situations. So basically, anytime you are trying to, or anytime you have an x squared, a variable squared, you're going to have to go ahead and we're going to have to factor these. And one of our answers might not work. So we have to plug it back into the original equation and see if it's a true statement. If it's not, then we go ahead and we cross them off. So we still are going to follow our steps for examples number 9 and 10. This is where we're going to have to go in and check for the extraneous solutions though. So I want to isolate the radical. Well, right now it is already isolated. There's nothing else for me to get alone. So I need to get rid of the radical. And to get rid of that, we square the square root. What we do to one side, we have to do to the other. So I'm going to be left with x plus 2 is going to equal x squared. Having that x squared tells me I need to check for an extraneous solution. I need to make sure that both of my answers are going to work. So before we get to that point, we have to get our answers. To do that, remember when you have an x squared, we need to factor. So we have to get all of this to one side and have it be set equal to 0, and then we're going to use our x method. So I want to move everything to the x squared. I don't ever want to move the x squared because I don't want it to be negative. So I'm going to subtract x and subtract 2. So I'm going to be left with 0 equals x squared minus x minus 2. Now I need to go ahead and I need to factor this. So I'm going to use my x method. Remember, it's a times c to get the top, so it's negative 2. B on the bottom, negative 1. So I'm looking for two numbers that multiply to negative 2 and add to negative 1. Well, I know that there's negative 2 and 1. Now here's the trick. If your a value right here is a 1, it has to be a 1. If it's a 1, then these two side factors are your factors. So I would have one as x minus 2, and the other one is x plus 1. So now I can go ahead and set each of these equal to 0 and solve them. So I'm going to get x minus 2 equals 0, and I'm going to get x plus 1 equals 0. So I'll have x equals 2 and x equals negative 1. So we're going to go ahead here and we are going to plug these back in and see if they both work out for us or if we have extraneous solution. So I'm going to plug 2 in for x for the original equation. See if that equals 2. So I get the square root of 4 equals 2. The square root of 4 is 2, so 2 equals 2. That checks out. That's good. So now let's go ahead and try the negative 1. So I'm going to get negative 1 plus 2 equals negative 1. I have the square root of 1 equals negative 1. Remember, a square root cannot equal a negative number. So I get 1 equal to negative 1, which is a not true statement. So my answer would be just x equals 2. So I want you to pause the video. I want you to try number 10 on your own. Come back, check your answer, and then we'll move on with the rest of the notes. So I know there's a lot of work here, but I got x equals 1 and x equals 3. Both of those are worked out for me, so I don't have any extraneous solutions, so both of those are my answers. If you got that one wrong, come chat with me before moving on with the rest of the video.